Well, good day, everybody. This is Chris at the Ancient Scholar. I hope this video finds you all doing well today. I just wanted to take a few minutes to talk about something. I've just now looking at the news and see that a debris field has been located. It was located earlier today. And of course, this is in regards to the Titan submarine that had a incident, shall we say, a few days ago, back on Sunday, just about a couple hours into a dive to the Titanic. And at this point, I think anyone who's watching this video is roughly familiar with the story, so I won't spend a whole lot of time rehashing the details of that. And so from what I gather, it looks like the current understanding of what may have occurred is probably a rapid failure of the pressure hull and subsequent implosion that resulted in the deaths of all 5 of the occupants within the submersible. At least that's what I gather from a couple of little news reports I've seen. And something I find interesting, and again, I don't mean to belittle this situation and all of the potential ramifications, and of course, I don't mean to belittle or make light of the fact that there are people that have died, their friends and families and acquaintances, and all of the suffering, sadness that surrounds this incident. But I just kind of wanted to talk about a couple of things that I found kind of interesting or compelling, perhaps would be a better word. And that is the fact that, from what I gather, the pressure hull, so that is essentially the container that the crew would be within, the container that protects the crew from the pressure of the surrounding water as they dive down, seem to have somewhat of a different construction, or a novel construction to it compared to other vehicles that have been designed to dive into deep waters. The traditional construction, and I want to be very clear, I'm not a structural engineer or anything like that, so I just have a very basic understanding of these things, but traditionally we see that pressure hulls are composed of high-strength steel alloys and titanium in some cases. And this has kind of a gold standard for creating pressure hulls for a couple of reasons. So first of all, we have been using various steel and steel alloys to construct pressure hulls for many decades. And so from a materials, solid state physics and engineering standpoint, we know these alloys very well, and we can predict their properties very accurately, and we can predict the behaviors of these steel, or these metals. So that's one thing. And the other thing is, you can create these objects and you can make them more or less one kind of you can make them out of one contiguous object. Okay, so you just have this one contiguous object, and with deep submersibles that go deep, you tend to want to have something that is roughly spherical, and that has to do with how the force, right? Because essentially you're dealing with what's called compressive forces. So you've got the pressure of the surrounding seawater, and a sphere, due to its symmetry, tends to be a very stable configuration that can withstand these compressive forces, and so they tend to be fairly spherical. And so you can build these spherical hulls made of one contiguous alloy, and that alloy has very predictable behaviors to it, right? And so that's kind of been the gold standard for submersibles, at least. And the submersible in question, the Titan, as I understand, they used carbon fiber or fiber epoxy to build the main pressure hull, and then they had titanium caps essentially on either end. So it was a cylinder, this thick cylinder of carbon weave, and then two basically titanium caps, and that is what collectively made up the pressure hull. And I just thought this was kind of interesting, aside from all of the other safety issues and kind of the ad hoc, frankly, cowboy type of stuff going on, or apparently going on with this. That aside, just looking at this just from a basic material standpoint, I find this kind of interesting. And I suppose a good question to ask would be, well, isn't carbon supposed to be lighter and stronger than steel? And wouldn't that not make an ideal material to create a pressure hull from, right? Because it's lighter, so it gives you buoyancy benefits. It's stronger, presumably. It would seem that doesn't corrode, right? At least carbon it doesn't tend to corrode in salt water. I mean, these all seem very beneficial. Well, here's the problem as I understand it. And please, if there are materials engineers out there, but please correct me if I'm wrong. But as I understand it, yes, carbon is stronger than steel when it comes to the certain contexts, and really where carbon is superior to steel or other metals is in something called tensile strength. And so tensile strength, imagine that this is a fiber, maybe this is carbon fiber. This is just some utility cord that I use to tie off auto belays when I'm rappelling and climbing, but this will work. And so tensile strength is when I pull on it like this, right? So imagine that I have a heavy object hanging from this and it's pulling down. That's tensile strength. And from a tensile strength standpoint, carbon fiber is lighter and, generally speaking, stronger than steel or metal alloys with the same kind of mass involved. All right. But here's the problem. We're not dealing primarily with tensile forces. In a submarine, we're dealing with compressive forces, right? So you're going down underwater, and approximately every 10 meters, or about every 33 feet, every 33 feet underwater, you get 33 feet of water up on top of you, and that adds what's known as an atmosphere of pressure. So under standard temperature conditions, if you are right at sea level, you are exposed to what we call 1 atmosphere of pressure. That's the collective pressure of the particles, primarily the nitrogen and oxygen in the atmosphere, that the pressure that those particles are exerting on your body at sea level. And that is about 760 millimeters of mercury, or 14.7 pounds per square inch, or we sometimes refer to this as a bar. 1 bar is 1 atmosphere. And then when you go under 33 feet of salt water, approximately, or 10 meters, you add another atmosphere of pressure. And then another 33 feet, another atmosphere, another bar, another 14.7 pounds per square inch, right? And every 33 feet you go under, more water on top of you, more pressure, right? And this is producing a compressive force. And as I understand it, carbon is not as resilient when it comes to compressive forces. So what they had to do to create the pressure hull for this submersible was they had to take little fibers of carbon and essentially wrap them up like so, right? Wrap them around into a cylindrical shape, and they would wrap them with an epoxy, like a sticky resin that sets in and hardens up and kind of locks those fibers into place, and then they would do another wrap. And so instead of this homogeneous, instead of kind of this one piece of homogeneous metal, you get multiple wraps of a composite or a mixture of carbon fibers and this epoxy that hardens up and acts as a kind of laminate. And so what happens is, over time, so you've got this carbon weave here, and we know that carbon is not as resilient to compressive forces as maybe other materials. So over time, you know, as you dive under, the pressure pushes on, and you can kind of get a little micro cracking. And because this is not a homogeneous chunk of metal, the carbon fibers can become separated, right? Because they're basically little fibers embedded within this epoxy matrix. And so the epoxy can kind of start cracking, and then the carbon fibers can begin separating from that matrix, and then the carbon fibers are not super resilient to these compressive forces, and you get what's called delamination, where the epoxy water comes in and kind of separates this mixture, this composite mixture of these carbon fibers in this epoxy matrix, and then you have failure of that pressure hull. And anyone who knows carbon knows that carbon tends to fail very rapidly. So it's a quick, marked kind of failure, and I suspect that's probably what happened. Is at some point during the dive, I am kind of going out on a limb here, so this is nothing definitive, but I would venture to say that this probably happened at the beginning of the dive when they were about an hour 45 minutes in. Apparently started having problems and then suddenly lost contact, and I suspect that at that point they were fairly close to the bottom of the ocean, which in that area was around 12,500 feet thereabouts. So you're looking at roughly speaking 6,000 pounds per square inch, a little less than 400 atmospheres thereabouts. This is just like off the top of my head calculations. So you're dealing with an incredible amount of pressure, incredible amount of compressive force. So I suspect that the hull probably failed very rapidly, and it imploded and basically instantly killed everyone inside. Maybe they were aware of something happening. Maybe they heard some cracking or popping or something like that. But I would suspect that fairly rapidly there was failure, and they were killed incredibly rapidly. So as horrible as that sounds, at least there wasn't any substantial suffering. In fact, I would doubt that they were even aware of what happened once the implosion occurred. It was just so quick and rapid, and it was just over with. So I don't believe that anything was at the bottom of the ocean and people were running out of oxygen and all that. I don't believe any of that happened. And from what I gather, I listened to the Coast Guard briefing that was done earlier today, And that's kind of what the briefing seemed to suggest, that there was a failure in the water column, and then it imploded, and the debris landed on the ocean floor, about 1,600 feet or so away from the wreckage of the Titanic. But I just kind of wanted to talk a little bit about the carbon aspect of it, because I think that's kind of a compelling situation, and a compelling topic to take a deeper dive in. And I would suspect there are probably people much more knowledgeable than me that are already opining on this. I don't think that my thoughts are unique, and there are probably some structural engineers that have much more detailed information and knowledge surrounding this. But I just wanted to give my thoughts on that. And again, I don't want to belittle the horror of what has happened, but I wanted to talk a little bit about the construction of that pressure hull, and it, in addition to all the ad hoc stuff that seems to have occurred in building this and implementing this submersible. This is yet another interesting choice that they went with for the use of materials that is, again, has certain pitfalls associated with it, and I wanted to point those out. All right, everyone, thank you so much. Take care, and we'll see you in the next video.